See, students, in the last class we were discussing some questions of NCERT. Question 6.7 D part we will discuss when all the students will come. Let us start discussing question 6.8. In an elastic collision of two billiard balls, is the total kinetic energy conserved during the short time of collision of the balls? Okay, so the question is, when I have two balls and when these balls, like tennis balls, when they will come in contact with each other, what will happen? Actually, the balls will deform. If I press them against each other, so the balls will deformed. So the collision is elastic collision, and we know that collision means initial potential is initial momentum is equal to final momentum, and elastic means initial kinetic energy of system is equals to final kinetic energy of the system. That is the meaning of collision and elastic. So now the balls are separated again. So this is during collision. Here the collision start, and this is during the collision, and this is after collision. This is before collision. So students, as this is elastic collision, so definitely here I have kinetic energy initial and here I have kinetic energy final. So here the initial kinetic energy and this is the final kinetic energy, and these two are same. Suppose this is 10 joule, this is also 10 joule, but during the collision it may not be 10 joule because there is deformation. So due to the deformation of the balls, here the energy will definitely be reduced because some of the energy is there. So it might be that here the energy has remained 8 joules. So that is the question, that in an elastic collision of the two billiard balls, so here these balls are billiard balls, is the total kinetic energy conserved during the short time of collision? So conserved means change in kinetic energy is 0. So is there any change in kinetic energy during the collision? Yes. Even during the elastic collision? Yes. Vinay, tell me.
The kinetic energy will be conserved in elastic collision.
Kinetic energy is conserved in elastic collision means the initial kinetic energy is 10 joule, final kinetic energy is 10 joule, but in between there is deformation, and energy due to deformation, the kinetic energy becomes 8 joule. Here the kinetic energy was 10 joule, here the kinetic energy is 8 joule, here the kinetic energy is 10 joule. So the question is, explain carefully with reasons that in an elastic collision of two billiard balls, is the total kinetic energy conserved during the short time of... Here is the kinetic energy conserved here? Is it same
No.
as... No.
No, sir.
No. So no, the kinetic energy is not conserved due to deformation. So during the collision, even in elastic collision, the initial kinetic energy equals to final kinetic energy. That's all right. But during the collision, the energy might be reduced. So the answer is no. During the short time of collision, the kinetic energy is no. The kinetic energy is not conserved. It is reduced. It is reduced due to deformation of the balls. Okay, again the ball regain their shape perfectly and get back their kinetic energy. Okay,
Sir, where this 2 joule energy go?
that energy has gone because the balls are deformed. So here again they regain their shape. They regained their shape. So their shape was changed, you can see. The balls were bent. So kinetic energy is not conserved here. Okay? During the collision. Because their shape is changed. So it is stored in the form of potential energy. Some of the energy is converted into, so here so you can say potential energy 2 joule. So some kinetic energy, part of the kinetic energy is converted into potential energy. So due to whenever there is change in shape, the potential energy is there. Potential energy is stored due to change in shape. Is this okay? So this was part A. Now part B is the total linear momentum conserved during the short time of the elastic collision of the balls. Is the total, okay, so kinetic energy is not conserved here, right? But what about momentum? Momentum is conserved. Momentum is conserved. Momentum is conserved even during the collision. So that's our part B. Now part C is what are the answers for an inelastic collision. If the collision is inelastic, then here in part A kinetic energy was conserved here, means initial kinetic energy is equals to final kinetic energy. Here also, but so this was the case when the collision was elastic. Now if the collision is inelastic in part C, inelastic collision, so then what will happen in case of inelastic collision? In case of inelastic collision, K is not conserved here. During the collision, not conserved. Here of course is not conserved after collision. But the momentum is conserved during collision also and after collision also. So this was your part C. Now next part D. If the potential energy of 2 billiard balls depends only on the separation distance between their centers, is the collision elastic or inelastic?
Elastic.
Okay. So why the collision is elastic? We are considering here
because
yes.
So because in elastic collision the conservative force is involved.
Okay, good. Your answer is correct. Yes. So the potential energy of 2 billiard balls depends only on the separation distance between their centers. So here the collision will be elastic Okay. Now we have let us do one more exercise question. So we have question number 6.8. So in this question 6.18, sorry, question is 6.18. The bob of a pendulum is released from the horizontal position A, and if the length of the pendulum is 1.5 meter, what is the speed with which the bob arrives at the lowermost point B? So we have a bob which is over here, and this is the length of the ball, means length of the string, and this length is 1.5 meters. What is the speed with which the bob arrives at the lowermost point B? So the bob will arrive here at this point, from here to here. So this length, definitely it is 1.5, and the velocity will be horizontal. So this was position A and this is the position B. Given that it dissipates 5% of the initial energy against the air resistance. So there is some air resistance and it has lost 5% of its initial energy. So students, here in this case, we'll consider that it is coming down due to gravitational energy, and this is the height, which is the same as length of the pendulum, which is 1.5 meter. So here the force that we are talking about is gravitational force, and in case of gravitational force, this is conservative force. So here the work done only depends on initial and final position, and in case of conservative force, mechanical energy is conserved. So mechanical energy is conserved. It means that initial mechanical energy, which is sum of kinetic energy plus potential energy, is equal to the final mechanical energy. So what was initial kinetic energy? So here the speed was 0, so kinetic energy was 0. There was only potential energy. How much was it? It was mgh. And here finally we have only kinetic energy, final kinetic energy, plus here this is the lowermost point, and we assume that the potential energy here is 0. Now the thing given is that the potential energy, while this conversion 5% of the energy is dissipated. So if there was only gravitational force, so then this was the scenario. But we have non-conservative force, So they are also known as drag forces. Drag forces like your friction or air resistance. So we have non-conservative force here, air resistance. So therefore mechanical energy will not be exactly conserved and it is reduced. And how much is it reduced? The kinetic energy final is not equal to this, but it is reduced by, kinetic energy is reduced by 95%. Or matlab it is 5% it is reduced, so the left is 95%. So means the kinetic energy final is equals to 95% of mgh. Is it clear, students? If there were only gravitational force, so then the mechanical energy will be conserved, but there is non-conservative force, so there is air resistance. So this is just for your understanding. You need not to write this in this question. So this is a note for your understanding. So here, due to non-conservative force, which is drag force, air resistance here, so kinetic energy is not exactly equal, but 5% it is lost. So final kinetic energy is 95% of the initial mechanical energy, that is this. So what is kinetic energy? So that is half mv square is equals to 95% means 95 upon 100 into m into g is 9.8 and height is 1.5. So this m will cancel out and you will find the value of v equals to under the root 2 into 95 into 9.8 into 1.5 divided by 100, and this comes out to be 5.3 meters per second. So students, this was question 6.18. Okay. Now we will discuss one more question, which is 6.7 D part. In inelastic collision, final kinetic energy is always less than initial kinetic energy. So we have to tell whether it is true or false. So let us see. Collision. Collision means initial kinetic energy is equal to, or initial momentum is equal to final momentum. Inelastic means elastic means what? Elastic means initial kinetic energy is equal to final kinetic energy, means there is no change in kinetic energy. What is inelastic? Inelastic means one which is not elastic. So means the initial kinetic energy is not equal to final kinetic energy, means change in this change. So here the change was 0, there was no change, so change was equals to 0, but here change is not equal to 0. So in inelastic, so if the K is not equal to 0, means kinetic energy initial is not equal to kinetic, so there can be two cases. If Ki is not equal to Kf, then there can be two cases. One is initial kinetic energy is greater than final kinetic energy, means K is lost. And in another case, K can be gained, means final kinetic energy is greater than initial kinetic energy. So normally this happens, generally this case happens, but whenever there is any explosion, I told you, like even bow and arrow, gun recoils, or a cracker blast, so in all those cases final kinetic energy is greater than initial kinetic energy. So students, this is the same case as we have discussed today in example 6.8. Then that even during the elastic collision, you have seen that during the collision, potential energy, kinetic energy was converted into potential energy even during the elastic collision. So here the potential energy, which was stored in the form of chemical energy in explosion in this suppose there is a cracker and it burst in two pieces. So in that case, you can see that initial kinetic energy was 0, but final kinetic energy of the system is definitely not 0. So that is the case. So explosion is a case of, we consider it as a case of inelastic collision. So the collisions which are not elastic are inelastic. So the answer for this question is definitely it is false. Okay, and you can see what is the definition written of elastic collision and inelastic collision in our book. So open NCERT page number 129. So even on page 129, you can clearly see what the elastic collision is. So initial kinetic energy is equal to final kinetic energy, but the kinetic energy during the collision time delta t is not constant. Such a collision is elastic collision. So this is that the kinetic energy during the collision time is not constant. This is question 6.8, that during the collision kinetic energy is not conserved, and before that it is clearly written that elastic collision is when the initial kinetic energy is equal to the final kinetic energy. So this is clearly written on page 129, definition of elastic collision. So definitely if Ki is not equal to Kf, then the collision is inelastic, and if the inelastic, then kinetic energy can be greater generally, but final kinetic energy can be greater in case of explosion, gun recoils, and bow and arrow case. So in all those cases we have this.